Okay, here we go. Let me talk about your assignment over Christmas. Your assignment over Christmas is from Chapter 10. Chapter 10 is actually one of my favorite chapters. I think the math is cool, and there's actually labs, like 2 of them or 3 of them that we can do that are sort of hard, but doable. So, over Christmas break, you need to go to Canvas. You can actually go to behsscience.com too, but no one cares. When you log in, if it looks like this or not, but whatever. You go to Unit 6, which is Chapter 10. Go down here to the Christmas assignment. It says complete this worksheet linked below. I pasted the worksheet in here, but the table looked terrible, so I just, whatever. So you just click here. And there are 8 problems. These 8 problems will take you anywhere from maybe like 2 minutes to do that one to 20 minutes to do this one. Now, this assignment will be supported with videos. Use the book as your primary resource as well as the videos linked below. I haven't made the videos yet. I know I have them somewhere, but I can't find them on Google Drive, Google Photos, YouTube, or that computer. So I'm pretty sure I have to remake them because I have no idea where they are. The videos will go over some of the things that you need to be able to do this. Some of these are hard, and if you cannot completely do them, that's fine. But don't turn in nothing. They will be due the first day we get back from the break. Is there questions on that? Okay, then once again it's found on Canvas. If you just log in, click on your AP class. It's down here in Unit 6, Chapter 10, Christmas assignment, and hopefully you're okay with that. Okay, now, in order to help you with that, I actually plan to teach you a little bit here. I think it's already there. Yeah, it's there. Come on. Everything's just kind of slow. Okay. Chapter 10, and I only have, 14 minutes? Is that correct? So I'm not going to go through this whole slideshow. We will after the break, but we're going to go through it in a big hurry after the break. I want to focus most of our class time in Chapter 10 when we get back on the labs. So Chapter 10 is all about gases, and it's pretty much one giant, well, it's not even giant. It's pretty much one math equation, and that's all we're going to focus on today is the math equation for Chapter 10. We'll worry about its derivation and all its interesting aspects when we get back. But for 15 minutes to help you with your assignment, we'll talk about the ideal gas law. All right? The ideal gas law. This is something you definitely have to memorize, but you'll have it memorized after today. Everybody does. The ideal gas law says that the product of pressure times volume is equal to the number of moles of gas times R, which is a constant, times the temperature that the gas is at. PV equals NRT. This law in science is known as PV NRT. You just memorize it. PV NRT. PV equals NRT. I'm going to define each one. So, pressure. And pressure can have a few different units. The easiest one is ATM. There's torr. There's pascals. There's millimeters of mercury, which is torr as well. And then if you watch us, or the news, in America we're weird, so we do inches of mercury. Pascals, Pascals. No idea, but sure. Sorry, I don't watch those things. But she has cool hair, I know that. All right. We are going to use ATM and torr 99% of the time. Torr is millimeters of Hg. It's just a different name. It's an Italian dude. All right. Volume. Okay, V is volume. And we'll usually use liters, but sometimes milliliters. It doesn't really matter. Whatever. Now, N is equal to the moles of gas. And what's awesome about that is, yeah, N means number. M is so many other things, they just go with N. Like meters, other crap. And it's just for number. Meters. So what I was about to say, what's nice about N being here is moles. I can attach moles to almost any other chapter we've ever done. So what's nice is I can take PV NRT and our picket fence and combine them and get just about a test question from almost every chapter. Sound good? Yes, I love it. All right, R is a constant. It's called the gas constant. And it is equal to 0.0821. Well, I don't know why I wrote a 1 twice, but 21. And it has a weird unit that I don't remember, but it doesn't really matter. It's 0.0821. If you want. All right, and then T is temperature, and we'll typically do that in Kelvin. All right, now, the easiest version of doing this problem is when you have your pressure in ATM, you have your temperature in Kelvin, and you have your volume in liters. If you're given something and something else, you should convert it to all those and then plug it in. All right, so a simple PV NRT problem. I'm going to move slides. Are we okay with that? It would say, what is the pressure if you have 3 moles of HCl gas at 298 Kelvin in a 3-liter flask, and I think I got them, the ones that you need. It is pretty easy. So if PV equals nRT, then pressure is equal to what? nRT over V. So now we just plug in. N is what? 3. R is? And T is already in Kelvin. It's 298. And what volume did I put it in? 3. So it turns out these will just cancel. That doesn't always work that way, but it did this time. So I take 298, multiply it by 0.0821, and that will give me my pressure. I'm going to guess like 27, 24. It's the pressure that the HCl gas is exerting on the 3-liter flask. It's ATM. That's not bad, right? Okay. All right, we complicate stuff when we don't just give you everything in the right way. So what's one way I could complicate this? Anybody? I could give it to you in Fahrenheit, which we won't ever do, but I could give it to you in Celsius. If I gave this to you in Celsius, and this shouldn't be too bad, this would have been 25 degrees Celsius, which you would have added 273. Do you remember that constant? Kelvin is equal to Celsius plus 273. So that's one way I could have complicated it. Any other way? All right, good. That's the most common. Instead of giving you 3 moles, I could have said you had 15 grams of HCl. And then you would just have to divide that by the molar mass of HCl, and that would tell you your moles. You okay with that? All right, the other way that we typically ruin things is we put the pressure in something else. So let's do a problem where we solve for volume. So volume's what I'm looking for. And let's say the pressure is equal to 781 torr. And I'll teach you what to do here in a second. We'll say that the temperature is equal to 15 degrees Celsius. And I'm going to say, we'll still give you the number of moles just to make it easy for right now, is 1.8 moles. All right. So now, there is a conversion factor that you need to know, and it's not bad, but you need to know for this problem that 1 atm, which is 1 atmospheric unit of pressure, is equal to 760 torr. So, if you're ever given torr, you simply need to divide it by 60, and that will always put it into ATM. Sort of okay with that? So now, the first step you would do is take this, divide it by 760. What would you do to the temperature? Add 273. And then you're ready to plug and chug, right? PV NRT says PV equals NRT. So V must be equal to NRT over P, correct? So just plug that in. What time are we out of here? 22. 3 minutes. Sweet. What did we end up with here? Anybody? What's that? 21? 41? All right. Liters. Okay. Sort of okay with this so far? If I can bring it up in the amount of time we have left. Shrink. I'm in trouble. There's my kids, everybody. Merry Christmas. Let's just pull this over fast. So here we go. This first homework problem. How many liters, so that's volume, 10 grams of methane. What are you going to have to do to the grams of methane? Convert it to moles just by dividing. Methane is just 16. So then you have that, and then you have the pressure. Okay? Number 20, what's the pressure of grams of air? And it gives you the average mass in a 3-liter container at 30 Celsius. Got to convert it to Kelvin. All right? Then they get more complicated after that. And we'll put some videos out there. Please read all of Chapter 10 over the break. Please log in, do this assignment, and you should be pretty much ready to roll for everything. What's that? No, you can print it off, or you can just put it on a piece of paper.